Today I will discuss about Wilcoxon signed rank test with Python. Hello, good evening. I am Dr. Nozrul Islam, Associate Professor, Department of Geography, Kuchbehar Panchanan Burma University. Before starting Wilcoxon signed rank test, we have to know what is ranked data. Ranked data are valuable values put in order according to some criterion, that is smallest to largest. There are several statistical methods such as Kendall's tau, Spearman rank correlation, Wilcoxon signed rank test, Wilcoxon sum rank test, sign test, t-test for matched pairs, or t-test for dependent samples, Mann-Whitney U-test, etc. are used for ranked data. Note that if ranks are tied, the usual procedure is to average the tied ranks. Now, question arises when Wilcoxon sign rank test and the sign test will be used. The choice between the Wilcoxon sign rank test and the sign test depends on the nature of your data and the research question you want to answer. If you have numerical data with definite scores and want to test for a specific directional reference, the Wilcoxon sign rank test is appropriate. If your data are not numerical or don't have a clear numerical order and you are interested in the presence or absence of a difference without specifying the direction, then the sign test is better choice. For example, Wilcoxon sign rank test. Suppose we have data before using any drug to any particular patient and after the use of any drug. There are three patients that has been given something new drug and the result of pressure in millimeter mercury are obtained. After using the drugs, these three patients show the result. In this case, you have definite numerical scores, that is blood pressure values before and after the drug treatment. The data are numeric and you can assume a continuous distribution of blood pressure. To test this, you would use Wilcoxon sign rank test to assess whether there is statistically significant difference in blood pressure before and after the drug treatment. For example 2 for sign test. Now let's consider a different scenario where you are studying the effectiveness of two teaching methods A and B to see which is one preferred by students. There are four students. Student 1 prefers method A, student 2 prefers method B, student 3 prefers method A, again student 4 prefers method B. In this case, you have non-numerical categorical data and there are no assumptions about the distribution of preferences. Therefore, to test this, you would use sign test. Now, Wilcoxon sign rank test. One relatively less known non-parametric statistical test is the Wilcoxon sign rank test or Wilcoxon t-test or Wilcoxon matched-pair test. It is used for paired data comparisons when dealing with related groups, non-normally distributed data, ordinal or interval data, and small sample sizes. This test assesses if there are significant differences in the mean ranks of paired observations, making it a versatile tool for various research scenarios. For example, it can help to determine whether there is a significant difference in blood pressure before and after treatment, regardless of whether the data are normally distributed. This is the condition when we have to use sign ranked test. So sign rank test should be used number one when the primary data consist of ranks, number two when samples are too small to form conclusions about the underlying probability distributions, and number three when data indicate that necessary assumptions about distributions are violated. We will discuss about the Wilcoxon sign rank test with the hypothetical data. The question is, imagine you are conducting a study to assess whether a tutoring program improves students' examination scores. Sample size is 10. Your research hypothesis is that the tutoring program has a positive effect on test scores. So before going to the Wilcoxon sign rank test, we have to take hypothesis. Number one, null hypothesis. The tutoring program has no effect. The median of the differences of its scores after and before is 0. And alternative hypothesis is the tutoring program has a positive effect. The median of the differences in scores is greater than 0. So this is the data. Here we will see there are 12 students we have taken, and before their result are shown here before tutoring and after tutoring. Step 1, calculate the differences between after and before scores of each student, and step 2, rank these two differences in absolute values from smallest to largest while keeping track of all the signs. So this is the difference: 78 minus 72, that is plus 6, 75 minus 68, that is plus 7, 80 minus 81 equal to minus 1. Like this we will get this data. Note that in 11 and 12 number student have the same numbers, so their difference is 0, and this data has been omitted from our result. Then the difference are arranged in ascending order. This is minus 1, minus 1, minus 1, and minus 2, 2, 2, and etc. These differences are arranged corresponding serial number of the students. These are the corresponding number, student serial number, and then we will get absolute difference. That means the plus or minus sign has been omitted in this group. Now we have to assign rank on the basis of absolute difference. There are several tied ranks. Suppose this is 1 and 1. So we can get 1 and 2 by adding 1 and 2, we get 3, and divided by 2, 1.5 and 1.5. Next is the 2 has also repeated. This is 3 and 4. 3 and 4, adding 3 and 4 we will get 7, and divided by 2 we will get 3.5 and 3.5. Like this we will get the ranks of the data on the basis of absolute difference. Step 3, now calculate the sum of the ranks for positive differences, that is W plus, and separately for negative differences. In our previous data, where we find 3.5, 5.0, 6.5, etc. are the positive values, and their sum is 48.5. And we have three negative values. and these are 1.5, 1.5 and 3.5, and we will get 6.5. Step 4, we have to determine the test statistic, which is the smaller of the two sums of ranks, W plus and W minus. So Wilcoxon sign ranked test statistic is minimum value out of, this is the maximum value and this is the minimum value. So minimum value is the test statistic in our case. Now step 5, we have to compare test statistic to the critical value for alpha. Generally it is 0.05 in the Wilcoxon sign rank table, or use statistical software package. In this case, with small sample size, that is number 10, it is typically easier to use table or software such as Python. Note that if a pair of scores are equal, that is the same value, then they are considered tied and dropped from the analysis and the sample size is reduced. In the data below, there are two tied scores pair, number 11 and number 12, and indicated as NA, not available, and the data has been reduced as we have seen in the previous table. Now, step 6 is the conclusion part. From the table, Wilcoxon sign rank test table, that we will get critical value 1.96 and p value is 0.037. It has been calculated from Python software. Since our test statistic W is 6.5 is greater than the critical value, that is 1.96, and p value is 0.037, that is less than our chosen alpha level, we reject the null hypothesis. This means there is a strong evidence that the tutoring had a significant impact on the student's score. With a significance of alpha, that is 0.05, we conclude that the tutoring program had a statistically significant effect on test scores. This is the Python code I have given here, and if you put this value in the Python, we will get the result critical value and Wilcoxon sign ranked p value, and the comment also given in the Python. This is the screenshot of Python code. For this, you have to open PyCharm and copy and paste this code in the PyCharm, and this is the run button. You have to click the run button and you will get the result in console button. Here you can see the critical value 1.9699, that is 1.96 rounded figure, and Wilcoxon sign rank test p values is also here we have obtained, that is 0.037, and there is a comment also, reject the null hypothesis. Thank you for watching my channel.